All right, so what I wanted to show you is where does this quadratic formula come from? And it's really just our idea of completing the square. So if you haven't watched the other completing the square videos, go back and watch those ones. Here I'm going to assume you've seen completing the square, and we're going to just do it on the general version of a quadratic. So if we're looking at a quadratic equation, every quadratic equation can be written like this: ax squared plus bx plus c equals 0. And if that's the case, then I can divide by a, and I can get, let's divide by a. And if I divide by a, then I have x squared plus b over ax plus c over a equals 0 over a. So I just divided everything by a. And that leaves me with just a single x squared. So now I can draw a box and try to complete the square. Now keep in mind, all we're doing is making a square, and a square is the same on both sides. So if I've got a certain number of x's, I have to cut that in half on each side of the square. In the earlier examples, I had things like 8x, so I put 4x on each side. I had negative 12x, so I put negative 6x on each side. I even did an example where it was like 7x, so I put 3.5x on each side. Here it's the same idea. I'm putting half of b over a, so it's b over 2a. When you've got b over a, b over 2a is half as big. So the outside of my box becomes x plus b over 2a times x plus b over 2a. When you multiply those two pieces, you get b times b, 2 times 2, a times a, b squared over 4a squared. However, that was extra. I just borrowed that from the bank. So whenever you borrow something from the bank, it's going to also give you a debt minus b squared over 4a squared. The c over a is just being copied down from before. The equals 0 is just being copied down from before. So here is our completed square. X plus b over 2a squared minus b squared over 4a squared plus c over a equals 0. What I'm going to do now is just solve for x. We started with x in two different spots that were unlike terms. We completed the square, so now x is in one spot. These two terms are fractions. They don't have the same denominator. So I'm going to multiply this one by 4, and I'm going to multiply it also by a. If I multiply it by a, it'll have a squared, and if I multiply it by 4, I'll have 4a squared. So I have x plus b over 2a squared. I have negative b squared plus 4ac over 4a squared equals 0. And I have that piece added on here. What I'm going to do next is just subtract all of this stuff from both sides and slide up here. So now we have x plus b over 2a squared equals, if I subtract a negative, it becomes a positive. So positive b squared. If I subtract a positive, it becomes a negative. B squared minus 4ac over 4a squared. I hope you can see how we're getting closer to the quadratic formula. Next thing we're going to do is square root both sides. Just like we did with our numerical examples, now we're just doing that with letters. Now I've got plus or minus square root of b squared minus 4ac. The square root of 4 is 2, and the square root of a squared is a. So now I've got 2a on the bottom. Last step is just subtracting b over 2a from both sides, and I have our quadratic formula. Negative b over 2a plus or minus square root of b squared minus 4ac over 2a. Because they have a common denominator, you get what we normally call the quadratic formula. It really is just completing the square. As an extra bonus lesson, this part here is our vertex. And this part is the distance that the roots are from the vertex. The distance from vertex to roots, meaning horizontally. I'll be real specific. It's the horizontal distance. Also, if you look at the b squared minus 4ac, this tells us what types of roots we have. If b squared minus 4ac is negative, then we're going to have complex roots because we're taking the square root of a negative. If it's positive, we're going to have real roots. If it's 0, we're going to have one root, and it's going to be real because the square root of 0 is real. The square root of 0 is 0. So you're not going to be asked to come up with the quadratic formula on a test, but I really always try to show you where these formulas come from. It's not something that was handed down from God. It really was a natural extension of, hey, we've got a problem that's got x squared. We can use squares to solve those problems. What if we tried to complete the square once and for all using a, b, and c for just arbitrary numbers? And if we can do that process for arbitrary a, b, and c, then we don't need to redo it every time we see a new problem. We've got a formula that works in general. So let me know if anything was confusing. Happy to explain more.